Now, yesterday we were doing about the pH. I'll just revise that one. pH is the strength of hydrogen ions and pOH is the strength of hydroxide ions. This is what we are studying yesterday. And if the pH is less than 7 acidic and more than 7 basic. And when it is 7, it is neutral. This much we are studying yesterday. Now, I brought this pH paper for you all to see it. You all can see this is a pH paper. This is a chart and this is the color of pH paper. The experiment is very simple. You take the solution, put onto the pH paper, immediately its color gets changed, match with the chart. Only that much you have to do it. The solution whose pH is to be found out, put it on this. See the color of pH paper. Whatever color you say, this is the color of the pH paper. And onto the pH paper, you put the drop of solution, the color of the paper gets immediately changed, and then you match with it. You can see the color is going from red onwards, and you can see somewhat like 7. This is like dirty greenish, that color it is coming. So, therefore, this is a pH paper, this is the chart, and this is a pH paper. Understood it? Whatever solution, if you put distilled water onto the pH paper, the color of the pH paper gets changed into this 7. This would be the color of the paper. And therefore, we say the pH is 7. Nothing to do. Just put the solution, match with the color, match with the chart, and that is what is the pH. Understood it? This is how one can find. This is what is known as pH paper, or even known as universal indicator paper. What is known as pH paper or universal indicator paper. Understood it? This is clear? Now, next, this statement you write down. Acids are classified into 2, strong and weak. Acids are classified into 2, strong acids and weak acids. Strong acids are like mineral acids. Strong acids are like mineral acids like HCl, HNO3, H2SO4. And weak acids are commonly taken as organic acid, like acetic acid, carbonic acid, that is H2CO3, etc. etc. So acids are classified into 2, strong and weak. Strong acids are the definition right now. Strong acids are those which dissociate completely into its ions in water. Strong acids are those which dissociate completely into its ions in water. Strong acid. Like when HCl is put into water, it is decomposed, it gets split into H plus Cl minus. Complete dissociation. And any acid which dissociates completely into its ions in aqueous is strong. So HCl, HNO3, H2SO4, these are mineral acid that get dissociated completely. Whereas we talk about this one, H2CO3, this is carbonic acid. It does not dissociate completely because you know that carbonic acid is a weak acid. The moment we open the bottle, carbon dioxide escapes out. So the dissociation is partial. Therefore, that acid is weak acid. So weak acid like this, we can take CH3COOH, that is vinegar acetic acid, lactic acid, citric acid, and all organic acids are weak, and these are strong acids. So strong acids are those which dissociates completely into its ions, and weak acids are those which dissociates partially. Similarly, strong alkalis or strong bases are known as alkalis, like NaOH, KOH, calcium hydroxide, etc. These are few alkalis. We are studying soluble bases are known as alkalis. So those bases which are insoluble and which get dissociated completely. Say for example, when NaOH is put into water, it dissociates into Na plus and OH minus. Complete dissociation. and that complete dissociation make it strong alkali. Understood? So strong alkalis are those which dissociate completely. These are few examples of strong alkalis. And next one, weak alkalis. Weak alkalis, like one example is NH4OH, and all others are bases. Bases means we are studying which are insoluble in water, so they dissociate partially. In fact, they don't dissociate at all. So they are known as weak. So strong acids, strong alkalis are alkalis which dissociates completely. NaOH, KOH, calcium hydroxide, lithium hydroxide. So we'll be studying that later. And strong, weak one is the other one. One such example is ammonium hydroxide plus all the bases. So we are classified acids in the strong and weak, and we are classified bases also strong and weak. The next one around salts are obtained. Salts are obtained. The salts are obtained by the reaction of neutralization. We are studying that earlier. When an acid is reacted by a base, we get a salt. So now understand it. When HCl is a strong acid and NaOH is a strong base, these are completely dissociated. So we get the product as NaCl plus H2O. So this is strong acid, this is strong base. So therefore, this product is neutral. And what I mean to say that its pH will be equal to 7. Understood the concept? So aqueous solution of sodium chloride, its pH is equal to 7. Why? Because it is a product obtained by the reaction of neutralization between strong acid and strong base. Clear? So any strong acid and strong base, H2SO4 plus calcium hydroxide, we will be getting calcium sulfate plus H2O. This is also neutral. So the reaction of neutralization between strong acid and strong base is neutral. Next, write down. The reaction of neutralization between strong acid and weak base. Strong acid is containing HCl and weak base as NH4OH, ammonium hydroxide. Strong acid and weak base, what do we get? We will be getting NH4Cl plus H2O. So this is strong acid, this is weak base. Therefore, since acid is stronger, so this is acidic in nature, or its pH is less than 7. So this is also the salt complaint. The reaction between hydrochloric acid and ammonium hydroxide, we get ammonium chloride as a salt, but this salt is a product obtained due to the reaction of strong acid and weak base. Therefore, ammonium chloride is acidic in nature. Therefore, its pH is less than 7. So, strong acid, weak base, the salt is obtained which is acidic in nature. The next one, weak acid and strong base. Strong base is taken NaOH and weak acid is H2CO3, carbonic acid. What is the product we are getting? We are getting Na2CO3 plus H2O. Carbonic acid gets reacted with caustic soda, we get sodium carbonate, caustic soda is obtained plus H2O. So this is weak acid, strong base, therefore it is basic in nature. Basic in nature means pH is more than 7. Understood the pH? So remember, all these are examples of the salt we get. All are the product. The reaction between acid and base, we are getting it. Acid and base, it produces a salt, but the salts are always, we say the salts are neutral. But remember, when strong acid and strong base are taken, it is neutral. And we are saying strong acid, weak base, it is acidic. So the pH will be less than 7. So the question is asked, what would be the pH of aqueous solution of sodium chloride? What would be the pH of sodium chloride solution? So what do we say? Its pH, it is a product of strong acid and strong base, therefore its pH is 7. Similarly, now the next one is weak base and weak acid. Let's say NH4OH, ammonium hydroxide as a weak base, and we are taking SuCO3 is a weak acid. So we will be getting NH4OH CO3 plus H2O. Ammonium carbonate is neutral. Weak and weak it is neutral. Understood it clearly? The question is asked this way. You may be given 3-4 solutions and will be asked you to find out how much, what would be the pH, more than 7, less than 7 or 7. How much is the pH, that won't be asked. That calculation will not be that. You can do only in the lab. You test the pH and identify the color and say what is its pH. Otherwise, we can say its pH can be less than 7 or more than 7. Now, one example. If a question is asked HCl and SuCO3 and the pH is given, suppose the two solutions are given, one pH is 1 and the second is 6. So one of the solution has got the pH 1 and other solution has got pH 6. The question is which of the two will be having this pH? So we can say HCl is a strong acid. So how much stronger the acid, the pH will be so much or less. So pH of HCl can be 1. And similarly, SuCO3 is a weak, therefore its pH can be 6. Now remember, 6 is less than 7. Less than 7 means acid. This is how we find pH and its application. Understood it clearly? 4 solutions may be given, different one, and will be asked you to find out which of them is acidic, basic, neutral. So in case the question is less mark, you have only say that this is acidic, basic and neutral. And if the question carries more, then you need to write down that it is a product of, you can find out. Say for example, one simplest example is aluminum sulfate, Al2SO4 thrice. So SO4 comes from H2SO4. This is strong acid. And aluminum, from which we get aluminum hydroxide, this is a weak base. So aluminum hydroxide and H2SO, strong acid, weak base. So aqueous solution of aluminum sulfate will be acidic in nature. This is another to find out. Clear? This is what we say pH. So importance of how to find out the pH is this way. All salts are neutral, that's what we have studied it earlier. But it's not necessary every solution will have a pH 7. When it is strong acid, strong base, or weak acid, weak base, it is 7. Otherwise, which is stronger, the pH will change accordingly. If the acid is stronger, pH will be less than 7. If the base is strong, the pH will be more than 7. Understood it? Okay, now the next topic in this one is the importance of pH in our day-to-day life. Importance of pH in our day-to-day life. Any examples? You read the book, it is given over there. You know, the ordinary milk has got its pH less than 7. Some are like approximately 6 point something. And to the milk, before it is being preserved or we send, it is said that they add a little bit of NaHCO3 or NaPCO3. Little washing soda is added to the milk, is what they say. When washing soda is added, they are saying washing soda is a salt of strong base and weak acid, so it is always basic in nature. So as long as this has got washing soda in it, the milk's pH is going to be more than 7. And when the milk gets spoiled, you are studied it is getting converted into lactic acid. Lactic acid means its pH is less than 7. So, as long as the milk has got washing soda in it or baking soda in it, what happens? That does not allow the milk's pH to fall less than 7. It keeps the milk more than pH more than 7, so milk will not be spoiled. Remember, when the milk is getting spoiled, it becomes lactic acid. And lactic acid means acid, pH is less than 7. So we shouldn't allow the pH of milk to fall less than 7, less than 6 or less than 6 in fact. And if it falls less than 6 means milk is spoiled. So you add any alkaline substance into that, that will make the pH of the milk more than 7. So no acid will be formed and the milk is preserved. This is one system. Understood it clearly? The next one, the insect stings. Supposedly the wasp has stung you. The wasp is producing methanoic acid. It's an organic acid. So onto the skin, a fraction of a drop of methanoic acid is injected by that wasp. So that gives you severe pain. So when it is an acid, the acid is to be utilized, we should have a base. Understood? So what we can do? Any basic substance, we can rub little bit of washing soda over that place. We can add little bit of quicklime. We can add slate lime. If we can apply soap. Why soap? Soap is always produced from caustic soda. So soap is alkaline. So these things are put so that the acid present in the body get utilized, and that is how the sting of the acid is utilized by the alkali. The pain get reduced. Pain will be there because it takes some time, but slightly it can be reduced when we use an. Understood? This is the importance of pH. The next one, the milk, your teeth. Teeth is made up of a calcium compound. The strongest compound, strongest thing in our body is tooth enamel. Now, your saliva's pH is less than 7. So we use toothpaste which is alkaline. You know, the food particles left over in our mouth, by the action of bacteria produce acid. And this acid eat away the tooth enamel. The tooth enamel is destroyed by acid that is present. So we must neutralize the acid present in our saliva. So how can we do it? It is done by brushing our teeth with toothpaste. Toothpaste is alkaline in nature. So when we brush our teeth with the toothpaste, which is alkaline in nature, that means its pH is more than 7. So what has happened? The acidity of the saliva is minimized and the tooth decay is minimized, prevented. This is the importance of toothpaste. Understood it clearly? The food particle, there is a carbohydrate present left in our mouth between the teeth, get decomposed by the action of bacteria into acid, and that acid will react onto the tooth enamel, and slowly the tooth enamel is getting destroyed. And that can be prevented. After eating our meal, we must brush it with the toothpaste, because when it is brushed, the alkali nature is produced onto the saliva and acid is utilized and the tooth decay is minimal. This is how one can do it. Understood? So what have I told you? The importance of pH. Many examples are there. Milk, I told you how to prevent its spoiling, toothpaste, insect sting, and all these are. Now, your stomach is having, that HCl is produced. It is used for the digestion to kill the germs and other things present in the food what we eat. The stomach has got, I think, 2% of diluted hydrochloric acid is there. And certain excess secretion of hydrochloric acid will produce, the person is known as acidity is produced. And how can we neutralize acidity? The acidity can be neutralized only by consuming an alkali. So one such alkali is, you are familiar about this, hygiene or milk of magnesia. Milk of magnesia contains magnesium hydroxide. So stomach has got HCl. We consume magnesium hydroxide. So what happens? Acid and base is neutralized. The acidity problem goes. Understood it? So in case excess secretion of acid, it creates a problem of this. Understood it? This is the importance of pH in our day-to-day life. pH is strength of hydrogen ion, remember. So when stomach has got more amount of acid, acidity problem, that excess acid is to be neutralized, and acid can be neutralized only by alkali, nothing else. So consume any alkali. Understood it? So don't think that we can consume caustic soda. Caustic soda is very corrosive, but that will burn your intestine, so we cannot. So we must consume a weak alkali. A weak alkali is like NaOH. Alright? So that is all I am stopping.